Welcome back, Algebra 2, to another fun episode of Math with Medrano. Make sure you have your notebooks out and a pen or pencil because we're going to go ahead and do problem number 3 in the notes. So I'm going to piece out in this little box right here. Okay, so let's take a look at number 3. So number 3 says solve x squared minus 4x plus 1 equals x minus 2 using your graph and then sketch the graph below. Okay, so as a reminder, whenever we've got a quadratic set equal to a linear type of function, they're asking us to see where the graphs intersect. So I'm going to be using my graphing calculator for this. Oh, and I'm not sure why that came up, but okay. We're going to be using our graphing calculator for this. Now, in our graphing calculator, we're going to put two different equations into our y equal signs. So one of our equations is going to be y equals x squared minus 4x plus 1. The other equation that I'm going to type into my graphing calculator is going to be y equals x minus 2. Okay, and so here's my graphing calculator. So the first thing I'm going to do is go to y equals up here and click on that. And I've already gone ahead and entered in those equations, but I'm going to show you guys how to do it. So to enter in the quadratic, we're going to type x first. We're going to click this x right here. To get the squared, the easiest button to push would just be the squared button down here. So we have x squared minus 4x, so 4, and then we're going to click this x again, and then plus 1. And there's my first equation. And then for the second equation, we're just going to go ahead and type x minus 2, so x minus 2, and then we're going to go ahead and graph that. So when I graph that at first glance, I can kind of see that these two graphs intersect, it looks like here between 0 and 1, and they cross again over here, and this looks like it crosses somewhere between 1, 2, 3, somewhere between 4 and 5, it looks like. 1, 2, 3, 4. Yep, somewhere between 4 and 5. But it doesn't look like it's directly on that x value of 4. So I'm going to go ahead and check my table first. To check the table, I'm going to click the second button and then hit graph. And so if I'm looking at the x value of 0, I don't see any common y values here. If I look at the x value of 1, I don't see any common y values here either. If I come down to 4 and 5, I don't see any common y values here either. So that means then that they intersect at a number that's not a whole number. And so to get that, we're going to use our calculator. So the first thing we're going to do is click second and then the trace button, because that's going to take us to this calculate menu. And then we're going to scroll on down and we're going to click on intersect. Okay. And so then the first thing we're going to do is it's asking us the first curve. So I'm going to hit enter, and then it's going to jump down to the linear graph, and I'm going to hit enter one more time. And then what I want to do next is place that third cursor right about where it looks like they intersect. So it looks like they intersect right here, and hit enter one more time. And then what's nice is that the graph gives me the intersection. So the quadratic and the linear intersect at the x value of 0.6972244, and then at this y value. So when I go to write that solution over here, I know that I'm going to just want the x value because in the equation, all I had were x's. So they intersect at x equals, I'm going to pop this back up again. So I'm going to put 0.697. 0.697. Okay, and so then that's one x value. We have to find the other one because remember, they cross again over here. So I'm going to repeat that process. I'm going to click second, calculate, go down to intersect, hit enter, and then I'm going to move this cursor a little closer to where that other intersection is, but it's still on the quadratic. So now it's closer to the other intersection point, hit enter, jump to the linear, hit enter again. And then I'm going to place that third one about where it looks like they cross. So I'm going to hit enter one more time. And again, the calculator told me that they intersected at this coordinate. So I am going to round this x value to 4.303. So at x equals 4.303. Okay, and then I just want to go ahead and quickly sketch out the solution like the problem asked. So this is not going to be the best thing. Sorry, guys. So there's my quadratic, and my linear looks like this. And they intersect here and here. So I'm just going to go ahead and write intersect. Okie dokes. That's it for number 3. Go ahead and try number 4 on your own and then come back and check the solution video.